I'm Brian Woodfield. I'm a professor of chemistry at Brigham Young University, and I'm the creator of Virtual Chem Lab. In the classroom, we often teach about experiments, about concepts, but we don't teach students the process by which those concepts and ideas and theories were discovered. And so Virtual Chem Lab allows students to go into this environment that isn't constrained, that allows students to discover the process by which we understand science and why we need these theories and how we understand the patterns and periodicity that we see in chemistry. The original idea of the software was recognizing that students in an instructional laboratory environment, they are cookbooking. So how can we fix the cookbooking problem? Obviously, a real lab is good for teaching certain things. I cannot teach technique using a mouse and a computer board and a flat screen. But a real lab is not good for doing some things. It doesn't teach students how to think because they're cookbooking. So the original idea was to create this virtual environment where we would kind of gloss over technique, where we would not be the primary focus, but the focus would become on the thinking side of things, the interpretation, the experimental design, the understanding what the results mean, and being able to put students in an environment where they're not constrained. Because students, if they feel artificially constrained, then they're going to think artificially constrained. I needed an environment where a student would be open-ended, where they just feel like there was unlimited possibilities of what they could do. We have clear data that shows if a student does a virtual experiment before going into the lab and performing the same or similar experiment in the real lab, that the real experiments is performed in about half the time. In other words, doing the virtual lab as a pre-lab, then doing it in a real lab, that you gain efficiency. Students know what they're doing, they know why they're doing it. Each one of our worksheets maybe 10 minutes, maybe 15 minutes to do the entire experiment. And then from that, instead of just telling students about an experiment, now they've experienced it. Now they understand the complications and variables associated with each experiment. A common worry I get from professors, instructors about adopting a virtual lab simulation is that it's going to replace a real lab. I will never recommend that we replace a real lab. A real lab teaches things that a virtual lab cannot. But what I claim is that a virtual lab can teach things that a real lab cannot, that you need to have both together. Not all the virtual labs are direct simulations, direct copies of what students are going to do in a real lab. There's more that you can do in the virtual lab than you can do in the real lab because of equipment. For example, in the quantum lab and the experiments in quantum chemistry lab, those experiments general chemistry students aren't going to have access to because the equipment is expensive, it's dangerous, and sophisticated. It's kind of beyond their level, but able to virtualize these experiments, students can now do experiments they would not normally have access to. So the virtual chem lab has access to those kinds, duplications of what they're going to see and access to experiments that they wouldn't normally have. Our experience is just get the students to do things instead of to listen to things. And just let them do this work. It doesn't matter if they even get correct results. Exposing them to a virtual environment where they have to think, you're going to win. Your students are going to think differently and they're going to be more engaged in the subject.